Okay, let's dive into this. Today, we're going to tackle a subject that's absolutely massive. It governs everything, and I mean everything, from the biggest, most mind-boggling galaxies out there to the tiny little gadgets we all have in our pockets. We are talking about physics.
So, think about it for a second. On one hand, you've got this spectacular whirlpool galaxy, billions of stars, so far away it's hard to even imagine. And on the other hand, you've got the smartphone sitting right there in your hand. I mean, they couldn't be more different, right? So what on earth could they possibly have in common?
Well, believe it or not, the answer is gravity. But it's even bigger than that. The real takeaway here is this incredible idea that the same fundamental rules, the very laws of physics, are at play everywhere. The force that's choreographing that cosmic dance of stars is the exact same one that makes water tumble over a dam. It's all connected.
And that brings us to our first huge idea. For all its incredible complexity, the universe seems to play by one single, consistent set of rules. Physics is really just our attempt to figure out what those rules are.
That's what physics is, right? At its core. It's this amazing quest to understand our world at the most basic level possible. It's not about memorizing a bunch of facts. It's a way of thinking, of searching for those simple, elegant laws that explain everything from why an apple falls to why a galaxy spins.
So that's great, but how do these huge cosmic ideas actually impact our lives? Well, it's pretty much a three-step journey. First, a scientist discovers some fundamental principle. Then an engineer comes along and figures out a clever way to apply it. And poof, that application turns into the technology that we all depend on every single day. And you can see the results of this literally everywhere. That GPS in your phone, it's constantly crunching physics equations about speed, distance, and even Einstein's ideas about time slowing down. And every single computer and smartphone exists because of a tiny little device called a MOSFET, a transistor that was born directly from a breakthrough in physics. From MRIs to microwaves, physics is the invisible engine that powers our modern world.
Okay, now to really get a feel for physics, you have to try and wrap your head around the insane range of scales it covers. I mean, we're talking from the unbelievably gigantic to the impossibly tiny. Let's start big. I mean, really big. Remember that whirlpool galaxy? The distance to it is a casual 1.4 times 10 to the 21st power miles. That's 1 billion trillion miles. It's a number so huge our brains just aren't really built to handle it.
Now, let's slam on the brakes and go to the complete opposite end of the spectrum. The diameter of a single hydrogen atom is about 10 to the minus 10 meters. That is 1/10,000,000th of a meter. And physics has to work and make sense across this entire incredible range.
So how in the world do scientists deal with these ridiculous numbers without getting totally lost? They use this fantastic tool called order of magnitude. You can just think of it as getting a ballpark estimate by rounding to the nearest power of 10. It lets us compare things that are wildly different in size in the way that actually makes sense.
Just look at this slide. It shows you just how powerful this way of thinking is. You can see a proton is 5 orders of magnitude smaller than an atom, and a human is a whopping 9 orders of magnitude smaller than the sun. By using powers of 10, these giant differences suddenly become manageable. We can even do quick calculations, like figuring out it would take something like 10 to the 19th hydrogen atoms to stretch all the way across the sun. It makes the incomprehensible comparable.
All right, so we know what physics is about and we know the incredible scales it works on. But how do scientists actually figure all this stuff out? Let's take a peek inside the toolkit they use to build our understanding of the universe.
First things first, we have got to clear up a massive misconception. You've probably heard someone dismiss an idea by saying, "Oh, that's just a theory." Well, in science, a theory is not a guess, not even close. It's a powerful, testable explanation that's been backed up by tons of evidence. Honestly, for a scientist, calling something a theory is just about the highest compliment you can give it.
So a key tool scientists use is a model. A model is basically a representation of something that's too hard or just impossible to see directly. A classic example is the Bohr model of the atom, where you picture electrons orbiting the nucleus like little planets. Now, we know atoms don't really look like that, but that model is still incredibly useful for explaining certain things.
A theory is a step up. It's much bigger than a single model. It's a whole framework that explains an entire group of things that are all related. Think about Einstein's theory of relativity. It explains gravity, why time can slow down, and how E equals mc squared. It's this massive, interconnected structure of knowledge.
And then you have laws.
A law is a super concise, very general statement that describes one specific pattern in nature. Like Newton's second law. Force equals mass times acceleration, F equals ma. It's a short, powerful equation that just describes a single fundamental action.
Now here's the most important part of the whole process. Science isn't about belief. It's a process of discovery. It doesn't matter how famous or well-loved a law or theory is. If a new, solid experiment comes along and contradicts it, then the science has to change. The evidence, and only the evidence, is king.
Okay, let's bring all of this home. We've talked about galaxies and atoms, theories and laws, which is all cool stuff. But why should any of this really matter to you in your day-to-day life?
Well, if you're thinking about any of these careers, you're going to be using physics all the time. An architect has to understand forces to make sure a building doesn't fall down. A pilot has to understand aerodynamics. A physical therapist uses the physics of leverage to help people heal. Physics is the bedrock for so many different professions.
And even if your job has nothing to do with it, physics answers all those little why questions about the world. Why is putting a fork in the microwave such a terrible idea? How does painting a roof white actually keep a house cooler? Physics has the answers. It explains how music is just vibrations in the air and how your car's engine fires up.
But beyond all the specific facts, studying physics just trains your brain to think better. It seriously sharpens your problem-solving skills. And because it's the most fundamental of all the sciences, if you get a good handle on physics, all the other sciences suddenly become a whole lot easier to understand.
When you get right down to it, studying physics is a grand adventure. It's like being an explorer on an uncharted ocean. It gives you the tools to look at the world around you, from the mundane to the magnificent, and to really appreciate the incredible beauty and order that's hiding just beneath the surface.
These laws of nature aren't things we invent. They are woven into the very fabric of reality, just waiting for us to discover them. Every new insight just pushes the frontier of our knowledge a little bit further, and the adventure is far from over. So what do you think? What will we find next?